All right, so today we're going to be working on algebraic relationships and how they look in tables and graphs. So first thing we're going to talk about is variables. And we're not talking about variables like x and y necessarily. We're talking about variables in terms of a scientific method. So we are needing to identify independent and dependent variables. So an independent variable is always on the x-axis on the graph or the first column or row in the table. Independent variables tend to be smaller numbers, and they also tend to be what does not change. It's more consistent. The dependent variable is always on the y-axis on the graph or on the second column in a table or column or row in a table. Let's go ahead and take a second to identify independent versus dependent variables in each of these examples right here. So in feet versus inches, the number of feet is going to be our independent variable. Our dependent variable would then be the number of inches. Again, if you notice the first column, independent, second column, dependent. On Gerald's foliage intake one, we have number of days versus amount eaten in pounds. So the first one is our independent, and our second one is our dependent. On our graph over here, we have number of baskets on our x-axis and number of baked goods on our y-axis. So that means that the x-axis is going to be our independent variable, and the dependent variable is going to be the number of baked goods. Another clue to remember is that your independent variables tend to have smaller numbers. So if you look at all of our independent lines, they have much, much smaller numbers than those that are on our dependent lines, because those are drastically changed by whatever rules we see when we do the algebraic reasoning. Let's go ahead and look down at rules to equations. We can represent rules from tables and graphs with equations. So we're going to be writing an equation to represent the rule that we find from each table and graph. There's really two ways that we see this. We see with addition and we see with multiplication. So, with addition, we would write the equation y equals x plus b. The x and the y represent the information from the table. The b represents the rule that we will find. So that's really where our focus is. The x and the y are just, if we were to plug in the information from the table, we would be able to find what b is. So let's look at this table in the next group. We have x value of 2, y value of 5, x value of 4, y value of 7, x value of 6, y value of 9. So if I'm looking at this, I can see that I'm not going to be able to multiply to go from x to y, because we're trying to find out what can we do to x to get to y. We're finding the rule instead of making the rule like we used to in ratio tables. So first thing we need to talk about is which one is the independent and dependent variable. So on our x one, our first column is always our independent variable, and our second one is always going to be our dependent variable. So let's go ahead and come up with a rule for this table. So how would I go from 2 to 5, from 4 to 7, and from 6 to 9? The only way that I can think of would be to add. And if I'm adding to 2, I would have to add 3. To go from 4 to 7, I would have to add 3. To go from 6 to 9, I would also have to add 3. Since all of those rules are the same, our rule would be to add 3. Then we need to write our equation in the same format as above. The only thing that changes is going to be the plus b. We're going to use our rule instead. So our equation would be y equals x plus 3. Now we're going to go ahead and take a look at the graph. With this graph, I want you to know that it's not as common to see additive graphs or addition graphs because they make a really slow rise and they don't start at the origin. So it doesn't start here, it starts way up here. So keep that in mind. Another thing is that they tend to rise or change really slowly. So if you look here, 3 is at 6, 2 is at 5, 1 was at 4. So it's really just adding each time. It's not changing much in between. Let's go ahead and identify our independent and dependent variables from this graph. So we have the x-axis, which means it's going to be the independent variable. And then we have our y-axis, which would be the dependent variable. Like I said, graphs for addition are not as common as the multiplication ones. So let's go ahead and move over to multiplication, and we're going to look at the equation that we're going to be using. So for multiplication, we will use the equation y equals kx. K represents a constant, so that means a constant change. This is multiplying, so technically the k and the x will be touching when you write it. The k represents the number that's in our rule. So if we look at our table, let's identify our independent and dependent variables. My x is going to be the independent variable, and my y is going to be the dependent variable. Now let's take a look at that data. So we go from 2 to 6, from 4 to 12, and from 6 to 18. So we need to figure out what change is happening here. So to go from 2 to 6, I know that I can add 4, but if I add 4 to the next line, it's not going to give me 12. So that means that it's a multiplication relationship. So what would I multiply 2 by to get 6? 3. What would I multiply 4 by to get 12? 3. What would I multiply 6 by to get 18? Also 3. Since they have the same rule, our rule would be to multiply by 3. Now we're going to go ahead and write the equation. The equation has to be written in the y equals kx format. So it would be y equals 3x because we're replacing the k with the number from our rule. Let's go ahead and take a look at this graph. This graph is a little bit different because it's sloped more towards the origin or the 0, 0. Each one has its own growth, and you can see that when it's getting bigger much faster. 3 is 9, 4 is 12, 5 is 15. So this is a much bigger growth, and it all would come back if I was to make all those into a nice line. It would end up going through the origin. I know that's an ugly line. Just leave me alone. Let's go ahead and identify our independent versus dependent variables. So on the x-axis, that will be our independent variable. On the y-axis, that will be our dependent variable. So keep this in mind as we're working with multiplication and addition. You're really looking for the rules. Now there's one note that I want you to keep in mind when it comes to these graphs. Your table also represents your ordered pairs for your graphs. And your graph, the coordinates, represent your table. So if you're unsure and need to find a rule from a graph, you can write that table out using those coordinates. Go ahead and flip to the back, and we're going to look at 3 examples.